Hello, this is Doina and this is the Raspberry Pi tutorial. Today I'm going to talk to you about the Raspberry Pi board. We're going to discuss some of its specs and some of its competition. We're going to look at how you can load the operating system into your Pi board. Thereafter I'm going to discuss how you can create a bridge between your Raspberry Pi and your computer or laptop. Then we're going to learn how we can remote into the Raspberry Pi. That way the only thing that you need to access the Raspberry Pi is your current hardware. Then I'm going to show you a fun project that we can do with the Raspberry Pi board and a Raspberry PiCam. I'm going to show you how you can put the two together, and we're going to look at the project. Alright, let's get started. The Raspberry Pi board is an amazing microcomputer. It has a 1.4 GHz quad-core processor, which you can see right here. The Broadcom 2837 is high-performance, low-power processor that implements ARM v7 architecture. The Raspberry Pi also comes with a 1 GB SD RAM. So essentially you're going to utilize a micro SD to load the operating system onto it, and then it will go inside of this micro SD card, like so, and we will look into that a little bit later. Also has an HDMI connection and support. The Raspberry Pi comes with 40 GPIO pins right here. So what does this mean? This means you have 40 potential connections to things like I/O devices or sensors. So what I would suggest is you go online and you look up the GPIO connection printout, and it's going to show you how each one of these pins can be utilized. That way you have correct implementation when you do your projects. The Raspberry Pi also has a 400 megahertz video core. Therefore you can use the PiCam to do some cool video projects. It also has 4 USB connections, which you can see right here, and it has an Ethernet cord connection. So overall, the Raspberry Pi microcomputer is amazing. It fits in the palm of your hand and it is really powerful. Alright, so let's talk about the competition. I'm not going to talk about the Arduino boards here because basically they can take input and turn it into valuable output, which yes, is very important in robotics and electronics applications, but it's not as advanced of a configuration as a microcomputer, which can do many of these tasks at the same time and on which you can do more complex computing. So I'd say a fair competition to the Raspberry Pi 3 is the BeagleBoard Black. It comes with a 1 GHz Citara processor, 32-bit architecture, 4 GB of onboard storage, as well as a micro SD slot so that you can expand the memory. It also has 92 potential pin connections, so a myriad of opportunities to connect to I/O devices and expand. While the BeagleBone Black processor, it outshines the Raspberry Pi on connectivity and expandable memory, the Raspberry Pi 3 has a CPU clock rate of 1.5 GHz, while the BeagleBone Black tops out at 1 GHz. So clearly, it is a faster processor. Also, the Raspberry Pi instruction set utilizes the latest ARM 64-bit architecture, and the Pi 3 has a 1 GB of RAM, while the BeagleBone Black has 512 megabytes. Also, as far as pricing, the Raspberry Pi 3 is priced between $35 and $40, while the BeagleBoard Black is between $49 and $60. So I'd say overall, for robotics kinds of projects, the Raspberry Pi 3 definitely outshines the BeagleBoard Black, which is its best competition. In order to download the operating system, you will need to go to raspberrypi.org/downloads. Here you'll have a variety of operating systems to choose from. I personally prefer the Raspbian as it is the original one and it should work well for the project that we are going to demo here. The Noobs operating system is another option that is easy to install and geared for beginners. One important distinction is that you can run Raspbian in headless mode, meaning that you can run it without having a screen or keyboard attached, which is not possible with Noobs, and is very important in robotics projects. Another distinction is that Noobs allows you to download a variety of operating systems on the same microcomputer. So what you are going to do is take the image of the operating system, and you're going to download it onto a micro SD card. An example, I'm using the ScanDisk micro SD card. It's a 32-bit. You can see it right here. And when you purchase it, it should come with a ScanDisk micro SD card holder, like so. And you will just place the micro SD card inside the holder, and this will go inside of your computer and be read. So you might or might not need the holder depending on your computer or laptop. So you are going to need the SD card reader to read, right? And you're also going to need some software to make the download possible, and we'll discuss this next. You're going to need an Ethernet cord like this one. You probably have one lying around. If not, they're fairly cheap to acquire at the store. And you're going to connect it to your Raspberry Pi like this, whereas this end will go in your computer of choice. So that's number one. You're going to definitely need this. And you need a computer that can accept an Ethernet cord. Also, you're going to need a cord for charging your Raspberry Pi, and we're going to use our laptop or computer as the source. To do so, basically you're going to connect it to your Raspberry Pi. You see here an Android-like connection point. That's how it connects. So next, you're going to navigate to raspberrypi.org/downloads. Once you arrive here, you're going to select Raspbian. Of the three options, we want the first one because it comes with the recommended software, and we will need that. You're going to download the zip. I will not do so because I have already downloaded it. And then you're going to go to the installation guide. Once at the installation guide, you're going to scroll down to writing an image to the SD card. Here we're going to select Etcher. This will take us to the main website where we can download the software. Okay, so now that we have everything open, we've downloaded our file right here, still not on our SD card, what we're going to do is use Etcher. We're going to select an image. Here's the image. We're going to choose where it goes. It already knows. It's going to the SD card. Just to check, this is in D drive, this is in D drive, and then you simply press flash. But say you're having issues with formatting the image that you just downloaded flashed onto your external drive. Should you have those issues, I would like to recommend this forum to you. So you can pause the video and just follow this link. It's under our Raspberry forums, and the question is, do I need to format when using Etcher? After you have safely removed the micro SD card from your computer, you're going to take it out and place it into your Raspberry Pi. I'm going to show you how to do it. Essentially, you want the picture side facing away from the front of the Raspberry Pi, like this, and it's in. Next, we're going to worry about powering the Raspberry Pi. Connect the USB charger to a USB connection on your computer. Connect that other end to your Raspberry Pi, as shown earlier. So now it's connected and powered on. And we're going to navigate to local area network, so network and internet, then network and sharing center. And here we're going to notice that we have our connection, access mode, everything. And then we're going to take our Ethernet cord and make the connection between our computer and our laptop and our Raspberry Pi, which you can see it here. And there we go, it's connected. And also it lets you know with these LEDs here. So So you should see those flashing. So we made that connection, and now returning to our screen, we can see this here. We're gonna go on our connection. We're going to go to properties, go to sharing, make sure it is not enabled. And then we're gonna click OK. And close. Go to the Ethernet 2. Go to properties. Scroll down to IPv4. Make sure obtain IP address automatically is selected. Open up the command prompt. ipconfig/all. We want the Ethernet adapter. And we can see right here, in my case, the auto configuration for IPv4 address is this number right here. So what we care about is the first three portions, because of course this last part is going to be assigned to a device that is using that kind of connection. And we're going to use this number when we create in the next steps. Okay, so now you're going to copy the first three parts of the IPv4 address as I have here. You're going to go back into your microSD where you have the operating system. You will go into command line.txt, and we won't change anything about this file except for we're going to set it equal to, keep the first portion the same, and the last number can be anything 0 through 255. I'm just going to pick 155. Save that. Exit out of it. And as a side note, make sure you don't forget to put IP in front of it. That way, when it does go and try to retrieve the IP address, it knows in fact that it is an IP address. Alright, so there's a few things that you're going to need to do now. One, you're going to need to download the LXDE, the XMINX server. To do so, you're going to go to this website, and you're just going to download it. You're going to download the most basic version. Don't change any of the settings that it comes with. Alright, so you're going to click that and launch it so it's running in the background. At the same time, you're going to go into, let's see here, you're going to into PuTTY. You're going to open up PuTTY. We're going to recall what our IP address was that we had selected for our static address for the Raspberry Pi. Now remember, your microSD is now in the Raspberry Pi. It's running. The Raspberry Pi is running. It's connected. So we're going to go 192.168.137.155, or whatever it is that you selected. You're going to have SSH selected here. Under SSH, you're going to expand that menu, go under X11 and enable it. Enable X11 forwarding. Once you've done this, click open. Now, this is the actual screen to log into your Raspberry Pi. Here at the top, you can see PuTTY. You can see the IP address it's logging into. Login is Pi. Password is Raspberry. Press enter. It logged in. Now we're going to run command start LXDE. And it's going to ask us We're going to say OK. And here we are. Next, we're going to learn how to connect via VNC, which is a much easier way to establish a connection with the Raspberry Pi for future use. We're going to want to navigate to this website. To do so, you go to Google. And you type in Real VNC Viewer. And you select the Download VNC Viewer option. This takes you straight to the download page where you need to be. Select your operating system, select the configuration, press download. Once you have done all that, you're going to click on it, and this is what you're going to see. Once we're here, do note I moved the taskbar above so it'd be easier to follow. Start. We're going to go here eventually under Internet VNC Viewer. However, first we have to configure a few things. Alex terminal, sudo raspi config. Alright, first we go to network options. Select the second option down if you're using Wi-Fi, of course. And in this case, I'm using Wi-Fi. I will select enter. It's going to ask me for the name of the Wi-Fi connection. Here you enter your SSID. Once you've done so and you click OK, it's going to ask you for a password. Please enter your password. Once you do so, you click OK. And then we go on to the next step. So I'm going to go ahead and hit cancel, however, since I've already established my Wi-Fi connection. So once you've done that, you want to make sure that in fact you have a connection. So just go down to finish, hit enter. And the way we're going to check that is if our Raspberry Pi can connect to the internet, it should be able to get an update. And as you can see, loading packages, and it's done. So I'm definitely connected to the network. So we go back to raspi config. Now we're going to go further down to interfacing options. So select interfacing options, fifth option down. And we have a lot of options here, but as we said, we're going to work with VNC. So we select VNC. And it's going to ask us if we wish to enable it. Our answer is yes. Confirmation, okay. So now it's enabled. We are done here. So now we have to go into the VNC server because we need the IP address of the Raspberry Pi. That is the new one since we've established a Wi-Fi connection. There we go. If you'd like, you can read through all this to familiarize yourself. But what you're really interested in is this new desktop is Raspberry Pi because it gives you an IP address right here. This is the IP address that we're going to use to establish the connection with our desktop or laptop, which we'll use to remote into the Raspberry Pi. We're going to either go to File New or hit Control N. You get this. Here we're going to enter 192.168.1.29, just like we have it here. And I'm just going to call it my Pi. And I'm going to click OK. Here it is, and just double click on it. Immediately it pops up this screen, so you might wonder what's the username and password. Same as before. It's the factory one. So Pi Raspberry. So important thing to note here, it takes you through a few settings, and you note there's a different background. Don't worry, you didn't access somebody else's Raspberry Pi. It's still your Raspberry Pi. It just shows up much neater on the real VNC. Alright, so a while later it is done with the system update, and it's saying that now you're set up and ready to go. Push restart, and we're going to do so. Alright, of course we're going to get this because we're also SSHing into it. We can just get out of this now. And it's restarting the Raspberry Pi and attempting to reconnect to the server. Alright, so after the restart, we can just go and log back in. can hit remember password. And there you are. Doesn't that look much better than what we were looking at earlier? Now remember, I've logged back into my Raspberry Pi, and this time I don't need to use the Ethernet cord. It is connected to Wi-Fi. You should see both a red light on your Raspberry Pi as well as an intermittent green light, letting you know that everything's running correctly and you are connected to Wi-Fi. So just to show you the start menu, you click on the Raspberry and you have many options here. At programming, you have a lot of options. We already have Python 3, integrated development. But what we're going to do next is we're going to go to our command line, which will be terminal now under accessories. And we're going to go to sudo raspi config and to advanced options. So we want the entire operating system available to us as a resource because we're about to download OpenCV and that takes a lot of space. That is the library we're going to use for the project. So we're going to click on expand file system. Root partition has been resized. The file system will be enlarged upon the next reboot. Okay? We're going to have to make some more space available. In order to do so, we're going to go to sudo apt get purge wolfram engine. Right, and next we're going to get rid of LibreOffice. So again, we go sudo apt get purge LibreOffice. Next we're going to discuss connecting the Pi camera to the Raspberry Pi. What I have here is a PiCam. It has a ribbon. The ribbon has a blue side and a silver side. And I have my Raspberry Pi. You'll notice there's a connector here that I've popped open. The connector is located between the HDMI right here and the Ethernet. We're going to take the ribbon of the Raspberry Pi camera, silver side facing towards the HDMI, and we're going to put it inside of the connector and press down. And once you've done so, this is what it will look like. The ribbon is inside the connector and the silver side is facing the HDMI. Now that we have set up the Raspberry Pi externally, we want to set up the PiCam internally as well. So we're going to go here to command line and go sudo raspi -config. Once we get here, we want to navigate to interfacing options. Press enter on camera. Would you like to enable it? Yes. Okay. And then we can finish here. Of course, in your case, since you haven't enabled it yet, you're probably going to have to reboot the Raspberry Pi. Once you have done so, let's test and make sure the camera is working by typing raspi still -o image.jpg. Let's see if it takes the image. And let's see what we have. So there's the image right there. We go to our file system, scroll down, and look for the image. There it is, an orange. We have installed the Pi camera onto the Raspberry Pi. We know that it's working. We've already tested that. It's time to look at some code and see how that would feel. So I've written a short algorithm here, and I'm also using the OpenCV library, which is a great machine vision library. I do not cover how to install it onto your machine in this tutorial, but there are many tutorials out there that can help you achieve just that. So if you don't have it on your Raspberry Pi, go ahead and install it and then just come back to the tutorial. So here I'm utilizing Pi camera. It comes pre-installed on the Raspberry Pi, NumPy, which you'll have to download, Time and CV2. I create an instance of the camera. I start getting raw input from the camera. Thereafter, I allow it to sleep, the program to sleep a little bit for the camera to warm up. Then I capture an image, save it as a JPEG, Then I bring the image back into the program, first as a grayscale, convert that grayscale to 3 channel so that it can be displayed side by side with the color image. Thereafter, I bring the image back in color, and I create a NumPy horizontal H stack so I can display the 2 images side by side. So let's run the code and see what that looks like. Let's go ahead and save it. Be easier to see. Image test. Go into image test. And there you have it. As you can tell by the lemon, this is in color, this is in grayscale. You can tell a little bit that the ninja in the background has changed as well. So I hope you enjoyed this tutorial. It was intended for the beginner to get you started with the Raspberry Pi. We've looked at its specs, we've looked into its competition, we've also investigated how to write an image onto the micro SD card. Thereafter we looked into how to remote into the Raspberry Pi. We also looked at integrating a Pi camera into the system. And we've also looked at a code example. So I really hope you enjoyed the tutorial, and see you in the next one.